Okay. Good afternoon to one and all. So, in the previous lecture of electrical machine first, in the second unit, that is DC motor, we have discussed regarding torque equation of DC motor, and we have solved some problem related to that. That is torque equation problem. Today, we will discuss about the next one point is that the characteristics of DC motor. Okay. So similar to that of DC generator, the characteristics in case of DC motor, it is also important. So by knowing the characteristics or by understanding the characteristics of DC motor, we are able to tell the behavior of the DC motor, or it may be we are able to tell the some properties of the DC motor, like mechanical characteristics, like electrical characteristics, or it may be different types of characteristics. According to this, we are able to tell some of the performance of that DC machine. Okay, similar to that of DC generator. आपण जे जनरेटर मध्ये characteristics बघितलेत, similar to that of in case of DC motor, the characteristics, it is also very important to know the behavior of the DC machine. See, it is very much important to know the characteristics of motor, to know the characteristics of the motor. Motorच्या characteristics, it is very much important, and there are different types of DC motor, because it enables the selection of specific type of DC motor for a specific purpose. Okay, now understanding the characteristics, we are able to select the DC motor for a particular application. एका पर्टिक्युलर ऍप्लिकेशन साठी आपल्याला जर मोटर सिलेक्ट करायची असेल, if we know the characteristics, that is output power versus efficiency characteristics, speed versus torque characteristics, or it may be armature current versus torque characteristics, such a characteristics if we know, then we are able to select the motor for our particular application having an specific type of motor. Specific type ची motor आपण select करू शकतो if we know the characteristics, or if we understand the characteristics. For selection of motor, it is very much important. Okay, so see, again there are main three important characteristics is that the speed, armature current characteristics, speed into armature current characteristic, that is load characteristics. Torque versus armature current characteristics, again it is load characteristics. And speed characteristics, that is speed torque characteristics. See, there are three types of characteristics. In that first one, that is speed armature current characteristics. Second one is that torque and armature current characteristics, and the third one is nothing but speed torque characteristics. So this is a very much important point. All of you understand very well, and also it is important from due to the exam point of view. Also it is very important while selecting any one of the motor for a particular application. Okay, so we want to discuss these three characteristics of different types of motor. Like we want to understand the characteristics of separately excited, self excited, or it may be DC shunt motor, DC series motor, and compound motor. या मोटरचे आपल्याला काय करायचे characteristics, that means understand करून घ्यायचे. Okay, now see, the important characteristics of DC motor is that the speed torque characteristics, first one. Second one is that speed armature current characteristics, and third one is nothing but torque armature current characteristics. See, we will see one by one characteristics of motor, that is different types of motor, in that shunt motor, series motor, and compound motor. Okay, see, in that first one, the characteristics of DC shunt motor. Shunt motor चे आपल्याला characteristics काय करायचे, understand करायचे. See, to study the performance of the DC motor, to study the performance of DC shunt motor for various application, the characteristics, it can be studied. So that means while studying a characteristics, we are able to tell the performance of that machine, that is DC shunt machine, for various type of characteristics understanding. Various types of characteristics ज्यावेळेस आपण understand करतोय, at that situation we are able to tell the performance of the DC machine. See, in that first one, torque versus armature current characteristics. torque versus armature current characteristics, speed versus armature current characteristics, and the speed torque characteristics. So these three characteristics we want to understand in each type of motor, like DC shunt motor, DC series motor, and DC compound motor. याच्यासाठी आपल्याला या characteristics काय करायचे, understand करून घ्यायचे. Now see the torque armature current characteristics, that is load characteristics, speed armature current characteristics, and the speed torque characteristics. So in that we will see one by one. That is first one characteristics, that is here it is shown the speed versus armature current characteristics. पहिली characteristic दाखवलेले speed versus armature current characteristics. Okay. now while understanding the characteristics, that is speed versus armature current characteristics, the speed of the DC shunt motor, it can be plotted on y-axis, and armature current of the DC motor, it can be plotted on x-axis. And once we plot the characteristics, then we want to know the behavior of the these types of motor. त्या मोटरचं किंवा त्या जनरेटरचं बिहेवियर काय होतं आपल्याला अंडरस्टँड करता येईल. सी, do you know that the DC shunt motor having an shunt field winding or the field winding, it is in parallel with that of armature. Field winding ही armature winding च्या parallel मध्ये आहे. Okay, field winding it can be in parallel with that of armature, and the mechanical and the supply voltage, that is electrical supply, it can be provided to that of DC motor. मोटरला काय केलं आहे, this is the armature of the machine, this one is the shunt field winding and having an resistance RSH, ही shunt field winding आहे, this is the motor armature, supply voltage V it can be applied, and load current IL it will be flowing from supply lines. Supply line करून काय होतोय, IL current flow होतोय. This one is the armature current and this one is the field current. Okay, see the speed armature current characteristics is nothing but we want to plot the speed of the DC shunt motor on y-axis, and the armature current of the motor it is on x-axis. X-axis ला armature current plot करायचे, y-axis ला we want to plot the speed of the DC shunt motor. DC shunt motorचं speed plot करतोय आपण, and on x-axis we want to plot the armature current. Okay, see what will happen when the armature current of the motor it will be increases. Normally the DC shunt motor it will be running on constant speed when it will be run on no load condition. ज्यावेळेस motor no load condition ला run होते, that means when it is running on no load condition, we have performed the practical also. When the motor it can be running on no load condition, ज्यावेळेस motor no load condition ला run होते, at that situation it will be running on a constant speed, or it may be we achieve the speed of the motor, it is constant value la speed. These characteristics, that means all characteristics, it can be derived by using two equations. दोन इक्वेशन वरून आपण derive करतो हे characteristics. You people know the equation, that is back EMF equation. EB is equals to 5P NZ divided by 60A. This one is the equation, and yesterday derived equation, that is torque equation. What is the formula for torque equation? Torque equation चा formula काय आहे? Formula for torque equation
9.55 into EB into I divided by N.
9.55 into EB into IA divided by N. हा एक अल्टरनेटिव्ह फॉर्म्युला झाला. त्याच्या अगोदर एक डिराइव्ह केला होता आपण, TA, टॉर्क TA इज इक्वल्स काय आहे तो
1/2
1/2 or we can represent 0.159 into phi P Z IA divided by A. Okay, phi P Z IA divided by A. Now, if the manufacturing constant, or it may be some constant, that is manufacturing parameter of the machine, it will be constant, like number of poles of the machine, it will be constant, number of conductors of the machine, it will be constant, and the number of parallel path of the machine, it will be constant. Baga, so if these terms are constant, then this equation it can be right. हे जे पहिले इक्वेशन आहे ती मी असं लिहू शकतो, that is n is equals to, or we can write eb is equals to eb, it is directly proportional to eb, it can be directly proportional to p constant, z constant, a constant, 60 constants. So we can write the equation eb is directly proportional to phi into n, right? No, so according to this we will rearrange this equation. So n, that is speed of the DC motor, it is proportional to the eb divided by phi. Similarly, in case of this second equation, if the manufacturing parameter, like poles of the machine, number of conductor of the motor, number of parallel path of the motor, it will be constant. The constant आहे, so our equation becomes 0.159 constant. Then number of poles of the motor, it will be constant. Then number of parallel path of the machine, it will be constant, and Z will be constant. So that torque equation becomes torque TA is directly proportional to IA. Torque TA, it is directly proportional to IA. Okay, sorry, not IA. Torque TA, it is directly proportional to phi into IA. Okay, see, torque TA, it is directly proportional to phi into IA. TA जो आहे, that is armature torque, it is directly proportional to phi into IA, and the speed of the motor, it is directly proportional to EB divided by phi. EB divided by phi. Okay, right? See, armature current of the motor, this one is the armature current, this one is the shunt field winding current, and this one is the supply current, or we can call it as a IL. Okay, we want to derive first one characteristics. आता ही जी diagram आहे, this characteristics is nothing but speed versus armature current characteristics. Speed versus armature current characteristics. So see, armature current is plotted on x-axis, speed is plotted on y-axis. At a no load condition, the motor, it will be running at a constant speed. मोटर कॉन्स्टंट स्पीडला रन होते नो लोड कंडिशनला. हे आपण प्रॅक्टिकल मध्ये पण बघितलेलं आहे. प्रॅक्टिकली वी हॅव ऑलरेडी रनिंग द मशीन ऑन नो लोड कंडिशन. व्हेन आर्मेचर करंट ऑफ द मोटर, इट विल बी इन्क्रीजेस. आर्मेचर करंट कधी इन्क्रीज होतो मोटरचा? IA. कन्सिडर द शंट फील्ड करंट और द शंट फील्ड वाइंडिंग फ्लक्स रिमेन्स कॉन्स्टंट, दॅट इज फाय कॉन्स्टंट आहे असं कन्सिडर करा. So when IA, it will be increases. कधी IA increase होतो? If the load increases, right? No, बरोबर ना? Hello.
Yes, sir.
Okay. If load increases, the load current increases. बघा मी डायग्राम वरून सांगतो तुम्हाला इथं. See, लोड इन्क्रीज झाला की सप्लाय कडून घेतलेला करंट इन्क्रीज होतोय, बिकॉज इट इज अन सेल्फ रेग्युलेटिंग मशीन. कन्सिडर करा, फॉर एक्झाम्पल द ISH इज 1 एम्पियर. वी आर मेंटेनिंग दिस करंट इज कॉन्स्टंट. हा करंट कॉन्स्टंट मेंटेन करतोय. ओके, IL हा या कंडिशनला 10 एम्पियर आहे. सो व्हॉट इज द व्हॅल्यू ऑफ IA? IA ची व्हॅल्यू काय आहे? IA ची व्हॅल्यू काय येईल? IA is equals to supply current IL minus shunt field winding current ISH. So supply current 10 आहे, ISH is equals to 1 आहे, so it becomes 9 ampere. Right? No, I am taking example. हे लक्षात आलं? Now हे लक्षात आलं का सांगा मला?
Yes, sir.
Now load on the motor, it will be increases. Load increase झाला की काय होतं? Torque increase होतो. If the torque increases, then automatically current taken from the supply, it will be increases. Now consider the current taken from the supply, it will be increases. Supply कडून घेतलेला करंट इन्क्रीज झाला. Suppose this current is nothing but 12 ampere. हा करंट काय झाला? 12 ampere झाला. Right? No, shunt field winding current remains same, तो constant maintain करतोय आपण. So again IA is equals to 12 ampere IL minus shunt field winding current is nothing but 1 ampere. so it becomes 11 ampere. So like that we are increasing IA. बरोबर. कसा IA increase करतोय आपण, एकतर सप्लाय करंट increase करून किंवा लोड increase करून. Okay, see, IA is equals to 11 ampere. That means like this we are increasing the armature current IA. What will happen when the flux remains constant? ज्यावेळेस flux constant आहेत किंवा generally DC shunt motor it is having an constant flux machine or it may be constant flux motor. ही constant flux motor आहे. So this is generally used for a constant speed application. जिथं constant speed application required आहे तिथं आपण use करतो. See, now we want to derive the characteristics. ही characteristics आपल्याला derive करायचे, that is speed versus armature current characteristics. See, if the flux of the motor it will be constant, then this first one equation becomes N is directly proportional to EB, right? No, flux constant आहे म्हणजे phi constant आहे, so the speed it is depends upon back EMF, that is N is directly proportional to EB of the motor. Okay, and do you know that the voltage equation EB चा फॉर्म्युला काय? EB चा फॉर्म्युला काय? EB is equals to
Phi P
IPMZ upon A.
I want voltage equation. Voltage equation चा फॉर्म्युला पाहिजे. I don't know. I don't want the back EMF equation. EB is equals to terminal voltage V. Voltage equation पाहिजे मला V minus IARA in the form of IARA. Right? No. So speed, flux ज्यावेळेस constant आहे त्यावेळेस N is directly proportional to EB. N हा directly EB ला proportional आहे. Formula for EB is nothing but V minus IARA. Also we are maintaining the supply voltage constant. Supply voltage पण constant maintain करतोय आणि आपण current काय करतोय, armature current change करतोय. Okay, so tell me, if the armature current it will be increases, what will be the change in the speed? Speed मध्ये काय change होईल सांगा. हाँ,
increase.
speed increase होईल. बघा, I will write here. En is directly proportional to EB when flux phi is constant. Phi is constant. So En is directly proportional to terminal voltage V minus IARA. Terminal voltage V minus IARA. Phi of the that is supply voltage किंवा terminal voltage same आहे, constant आहे, ते 220 किंवा 230 किंवा 240 असेल. I am changing the armature current IA. If the armature current increases, armature current increase झाला, what is the effect on EB and then what is the effect on speed? Speed वरती काय effect होईल? काय इफेक्ट होतोय? What? Hello? हाँ.
If B increases, then phi also B increases, then speed is increases.
I think you have not understand the concept. See, this is the flux field winding. This one is the armature of the DC motor. And here it is supply, it can be provided to that of DC machine, that is V volt. Right? No. Supply voltage remains constant. Here it is IL. Here it is ISH. Here it is IA. Okay. So see, the flux of the machine it will be constant. That means ISH is constant. ISH constant आहे असं आपण consider करते, or it may be in case of DC shunt motor the field remains constant. We are maintaining field constant. According to this equation, N is directly proportional to EB divided by phi, so that the flux phi remains constant. So we have written the equation N is directly proportional to EB. Okay. Again, the formula for EB is equals to N is directly proportional to V minus IA RA. V minus IA RA. Now, supply voltage remains constant and we are increasing the armature current. Armature current काय होते? Increase होते. Okay. किंवा मी इथे इक्वेशन लिहितो EB is equals to V minus IA RA. Now see, if the armature current increases, what is the effect on EB? EB वरती काय इफेक्ट होईल?
Decrease होणार sir.
EB is decreases. And according to this equation, En is directly proportional to EB. If EB decreases, what will happen in case of speed? EB decrease होत असेल तर स्पीड काय होईल?
Decrease होणार sir.
Because there are direct proportion na. Okay. So En is directly proportional to EB. That means if armature current increases, the drop across this back EMF it will be increases. If the drop it will be increases, hence the back EMF it will be decreases. If the back EMF it will be decreases, so the speed of the DC shunt motor it will be decreases slightly. Okay, so the graph it will be like this. Initially at a no load condition, the speed of the DC shunt motor it is constant. DC shunt motor the speed काय आहे? Constant आहे. This can be shown by this line. Again, the speed of the DC shunt motor it will be slightly decreases when the armature current is increasing. So बघा, जसं जसं armature current increase होईल तसं तसं speed काय होतं? Slightly decrease होत जाते. So this is the first one characteristics of DC motor, that is speed versus armature current characteristics. Speed versus armature current characteristics. Getting? लक्षात आलं का ही characteristics? How it can be proved?
Yes sir.
कशी प्रूव्ह झाली इक्वेशन वरून? सो ही कॅरेक्टरिस्टिक्स अशी येते, त्याच्यासाठी प्रूफ आहे. आय हॅव टेल दॅट प्रूफ अकॉर्डिंग टू इक्वेशन वरून ते प्रूव्ह होतं की ही व्होल्टेज काय होतं? डिक्रीज होतं. आपण लोड टेस्ट कंडक्ट केले. वी ऑलरेडी कंडक्टेड द लोड टेस्ट ऑफ द डीसी मोटर. इन केस ऑफ लोड टेस्ट, इफ द लोड इन्क्रीजेस, द स्पीड ऑफ द डीसी शंट मोटर इट विल बी डिक्रीज होत होतं ना? तुम्ही रिडिंग घेतलेले आहेत बघा. So similarly, like this characteristics shows that the speed versus armature current relation of the DC shunt motor. DC shunt motor's speed versus armature current relation. Getting? First one characteristics. Getting no?
Yes sir.
Okay. Now we will derive the next one characteristics. Torque versus armature current characteristics. Okay, torque versus armature current characteristics. See, again the torque versus armature current characteristics of DC motor, it can be derived in this equation. या इक्वेशन मध्ये या ग्राफ मध्ये derive केलेले बघा. So see, the torque, what is the formula for torque? Torque चा formula काय? Torque TA is equals to torque TA is equals to torque equation
1/2 pi.
ठीक आहे. 1/2 पाय लिहा किंवा 0.159 लिहिले तरी चालेल. 1/2 पाय phi PZ IA divided by EA. See, the initial parameter or the manufacturing constant, that is manufacturing parameter, number of poles of the machine, number of conductors of the motor, and number of parallel path of the motor, it will be constant. Also 1/2 pi it is constant. So the torque equation becomes TA is equals to some parameter constant K into phi into IA. So that we can write this equation TA is directly proportional to phi into IA. Right now? TA, that is armature torque TA, it is directly proportional to phi into IA. See, the flux of the motor it will be taken as a constant. DC shunt motor चे flux काय आपण constant consider करतोय. If the phi it will be constant, that is phi is equals to constant, then torque TA is directly proportional to IA. Torque TA is directly proportional to IA. See, if the armature current IA increases, what will happen in case of torque? armature current IA increase झाला, what will happen in case of torque? Or if the torque increases, what will happen in case of IA?
Increases.
IA also increases if the torque increases, or the vice versa. That means if the torque increases, the IA increases. See, that means armature current increases as the same proportion the torque of the machine it will be increases, or the torque of the machine it will be increases at the same proportion the current IA of the motor it will be increases. Okay, and torque kadi increase hoto? If the load on the motor it will be increases. That means if the load on the motor it will be increases, according to that the torque of the motor it will be increases, and according to this equation, if the torque of the motor it will be increases, in the same proportion the armature current of the motor it will be increases. Okay, so it gives an linear proportion. Okay, it gives an linear proportion. म्हणजे जेवढा आर्मेचर करंट इन्क्रीज होईल तेवढाच टॉर्क TA काय होईल, इन्क्रीज होईल, किंवा त्याच्या सेम प्रपोर्शन मध्ये टॉर्क TA काय होईल, इन्क्रीज होईल. सो सी इट विल गिव्स अ लिनियर proportion. Okay, see, armature current it is plotted on x axis, torque of the motor it will be plotted on y axis, and if the armature current increases, the torque of the motor it will be increases, or the torque increases, जसं जसं torque increase होत जाईल, suppose at this value somewhat torque of the machine it will nothing but 10 Newton meter. At that situation armature current suppose 1 ampere, armature current काय आहे, 1 ampere आहे. Okay, now if the torque it is at this value, suppose torque जो आहे तो या value ला आहे, suppose it is nothing but 20 Newton meter, at the same time the current of the motor it is nothing but somewhat 2 ampere. Okay, like this it gives a linear proportion. So this curve it will be gives as a linear relationship and passing from origin, or it is a straight line which is passing from origin. Getting? And proof for that is nothing but according to torque equation. हे त्याचं proof आहे. Getting? That is torque versus armature current characteristics.
Yes, sir.
Okay, now similarly we will derive next one characteristics is that the speed versus torque characteristics. Speed versus torque characteristics. Okay. Okay, see, again these characteristics it can be derived from these two equation. मी आता जे दोन इक्वेशन सांगितले सेम इक्वेशन वरून आपल्याला डिराइव्ह करायचे. So one equation is nothing but torque TA is directly proportional to phi into IA, and speed of the motor it is directly proportional to EB divided by phi. Again, if we represent EB is equals to terminal voltage V minus IARA divided by flux phi. Now the relation between torque and the armature current and the speed and the armature current are, it can be shown in this figure. Okay, see, and the relationship between speed torque can be drawn in this figure. याच्यामध्ये बघा speed and torque चं relation draw केलेलं आहे. The speed of the DC shunt motor it can be plotted on y axis. Torque of the DC shunt motor it can be plotted on x axis. What will happen if the torque increases? Torque increase झाल्यामुळे काय होत होतं? Or suppose before that we are considering if the load on the motor it will be increases. मोटरचा load increase झाला. What will happen regarding torque?
Increases.
Okay, if the load on the motor it will be increases, then the torque of the machine it will be increases. According to proportion, if the torque increases, what happened regarding armature current?
It also
Increases.
It is also increases. Okay, so that means if the torque increases, armature current of the machine it will be increases, and if the armature current of the machine it will be increases, according to this equation En is directly proportional to V minus IARA. Torque increase झाल्यामुळे armature current increase होतोय. If the armature current increases, this drop it will be increases. If this drop it will be increases, that means EB of the motor it will be decreases, and if EB of the motor it will be decreases, what happened regarding speed? EB decrease झालं, speed
Decreases.
Speed is also decreases. So that this curve, it will be like this. That means speed of the DC shunt motor or the speed torque characteristics, it will be like this. When the torque of the motor, it will be increases, the speed of the DC shunt motor, it is slightly decreases from नो लोड. ही जी काय कंडिशन असेल कॉन्स्टंटची ती नो लोडची असेल. at no normal running condition or the no load condition, the motor it will be running on a constant speed. Constant speed ला रन होत असेल, सपोज 1500 rpm ला रन होत असेल. if the load increases, then the torque increases. if the torque increases, ia increases. if the ia increases, IARA drop increases. if the IARA drop increases, the EB decreases. And if the EB decreases, the speed of the motor, it will be decreases. So the speed, it will be slightly decreases or it is less than that of no load speed. No load speed पेक्षा speed काय असेल, less असेल. Okay, getting? So see, from the above two characteristics of DC shunt motor, किंवा आपण वरच्या ज्या दोन characteristics derive केलेले आहेत, from that characteristics, from the above two characteristics of DC motor, from above two characteristics of DC motor, the torque developed and the speed at a various armature current of DC shunt motor, it will be noted. And if the value are plotted, then the graph representing the variation of speed with torque developed is obtained. Variation of speed with torque developed, it can be obtained. Okay, it is obtained. And the curve resembles that the speed versus current characteristics, as the torque is directly proportional to the armature current. Torque is directly proportional to that of armature current. Okay, so torque armature current ला proportion आहे. Torque increase झाला की armature current increase will. If the armature current increases, the IARA drop, it will be increases. IARA drop, it will be increases. That means EB decreases. If the EB decreases, then the speed of the motor, it will be decreases. So the speed or the curve, it will be obtained slightly less than or reduced to that of no load curve. No load curve जो असेल त्याच्यापेक्षा कमी speed काय होईल, reduce होईल. Okay, getting? So this is the speed torque characteristics of DC shunt motor. Getting? No, लक्षात आलं?
Yes, sir.
Okay, now next one characteristics is that, so these are the three characteristics of shunt motor. Similarly, we want to discuss the characteristics of DC series motor also. So see, these are the some of the application of DC shunt motor. हे DC shunt motor चे application आहेत. In that, the DC shunt motor are generally the constant speed machine or the constant speed motor, because at a normal running condition, the speed of the DC shunt motor, it will be constant. Also, we are maintaining the flux of the motor is constant. So the speed of the motor, DC shunt motor, it will be the constant speed application. Okay, so DC shunt motor, it will be generally used as a constant speed application. So where or such application where the requirement of the speed or we required a constant speed motor, at that situation we use these types of machine. ज्या application मध्ये आपल्याला constant speed require आहे, okay, we required a constant speed, such application we use the DC shunt motor. In that first one application of DC shunt motor is that the lathe machine. Okay, lathe machine. Second one is that drilling machine. For drilling machine, it will also require a constant speed. Constant speed पाहिजे. Okay, so here the constant speed requirement is there. At that situation, we use this DC shunt motor. First one application is that lathe machine. Second one is that drilling machine. Third one is nothing but grinders. Fourth one is nothing but blowers. Fifth one is nothing but compressors. So see, all of you keep in mind here, the constant speed requirement is there. The constant speed requirement आहे. At that point or at that application, we are using the DC shunt motor. Okay, we are using a DC shunt motor. Okay, getting?
Yes, sir.
Okay, so these are the three characteristics of DC shunt motor. and these are some of the application related to that. Now we want to derive the same characteristics related to DC series motor also. Series motor चे आपल्याला characteristics काय करायचे, derive करायचे. Again the characteristics, it can be derived by using these two equation, that is torque equation and the back EMF equation. Equation of back EMF and the torque equation. According to these two equation, we are deriving the characteristics of DC series motor. See, here this one is the diagram for DC series motor. In that, why it is called as series? The field winding of the motor, it can be connected in series with that of armature. Field winding motor ची जी काही field winding असेल, so the field winding of the motor, it can be connected in a series with that of armature. Armature च्या series मध्ये काय. So this is the supply voltage. Here it is load current IL. Here it is series field current ISC, and this one is the armature current IA. So in case of DC series motor, the current flowing through the circuit, that is IL is equals to ISC, it is equals to IA. That means all the current remains same. All current kaya hai remains same hai. Okay. So again we want to derive this characteristics 3, torque versus armature current characteristics, speed versus armature current characteristics, and the speed torque characteristics. Speed torque characteristics. Okay. See, in that first one characteristics we will derive, that is torque versus armature current characteristics. Okay. Tell me the equation, that is torque equation. Torque equation काय आहे? The equation of torque TA is equals to 0.159 phi PZ IA divided by A. If the pole is constant, Z total number of conductor is constant, armature parallel path is constant, and 0.159 is constant. So the torque equation becomes torque TA is directly proportional to phi into IA. Okay, TA जो आहे तो फ्लक्स phi ला as well as armature current IA ला काय आहे, direct proportion आहे. See, we want to derive the torque versus armature current characteristics. See, when in case of DC series motor, the magnetic flux for a DC motor, it is proportional to the armature current. आता याच्यामध्ये फ्लक्स आहे, फ्लक्स मधून फ्लो होणारा करंट कोणता आहे, फील्ड मधून सिरीज मोटरच्या. This one is the field winding, this one is the armature winding, and here it is supply voltage. या फील्ड वाइंडिंग मधून फ्लो होणारा करंट कोणता आहे,
आर्मेचर
सेम करंट आहे ना. दॅट मीन्स वी हॅव रिटन इक्वेशन IL is equals to IA is equals to ISC. ISC means IA, we can put IA, or it may be we can put IL. See, if the armature current increases, armature current increase झाला, okay, that means if armature current increases, so in case of DC series motor, phi is directly proportional to IA. IA increase झाला की flux phi increase होतील, right? No.
Yes, sir.
Yes.
Because त्याच्यामधून फ्लो होणारा करंट कोणता आहे, तोच आहे. So see, instead of putting IA phi here, I am putting IA here. So my equation becomes torque TA is directly proportional to IA square. असं लिहू शकतो का मी?
Yes, sir.
Okay, that means phi is directly proportional to IA. So that I will write equation torque TA is directly proportional to IA square. See, up to this will happen up to the saturation point, or it may be one saturation point. After saturation point, what will happen? The flux remains constant. एका saturation point ला काय होईल, flux phi constant राहतील. So the torque equation, it will be TA is directly proportional to only IA. कारण phi जे आहेत ते constant राहतील. So after that, torque TA is directly proportional to IA. Before that, torque TA is directly proportional to IA square. So see, it will give one relation. Torque TA is directly proportional to IA square. That means if the current increases in the square format, then the torque it increases, or the torque it is proportional to the square of current. Torque जो आहे, it will be proportional to that of square of current. Okay, torque TA is directly proportional to the square of current. See, that means if current increases in the square times, then the torque increases in the one time. Baga, what I am telling, suppose current increase झाला 2 ampere ने increase झाला, what will be the value of torque? TA is directly proportional to IA square, that means 2 चा square. So torque TA is equals to 4, right? No, or torque TA is directly proportional to 4. So see, up to magnetic saturation point, the curve, it will be like as a one parabolic path. So see, the relationship between torque and armature current is therefore of the form of parabola, or it will be like as a one parabolic path. At the saturation of the field winding, it will be happen, or at the saturation point, the flux phi is constant. म्हणजे परत किती जरी करंट इन्क्रीज झाला तर फ्लक्स फाय काय राहतील, कॉन्स्टंट राहतील आफ्टर सॅच्युरेशन. ओके, आफ्टर सॅच्युरेशन the flux phi remains constant if we again increase the armature current. परत जर armature current increase केला तर flux phi काय राहतील, constant राहतील. So at that situation our torque equation becomes, if the flux phi is constant, then torque equation TA is directly proportional to only IA. As the IA increases, torque TA it will be increases. That means after saturation point, the curve it will be like as a straight line, or it will be a linear curve. As the armature current increases, the torque increases. Again armature current increases, the torque increases. So the curve, this curve, it will be nothing but the torque versus armature current characteristics. That is, up to saturation point, the curve becomes a parabolic path, and the after saturation point, the curve it will be like as a straight line. तो क्या है, straight line. See, with increase in the IA, the field flux increases linearly, but due to the saturation of the core, beyond a certain magnitude of the IA, the increase in the flux is negligible. So thus TA is proportional to the square of the IA up to saturation point, and after saturation point or the beyond saturation point, the torque it will be varies linearly with that of armature current. Armature current ला linearly काय होईल, ते vary होईल. So see, so from this torque load characteristics, or it may be it will be linearly curve. So it will observe that the DC series motor started on load because a very high starting torque. Okay, it is having a very high starting torque. We will discuss these characteristics next, but this characteristic is nothing but torque versus armature current characteristics. If the armature current increases up to saturation point, the flux is directly proportional to IA, so that torque is proportional to the square of current. So it will take one parabolic path, or it will be like as a parabola, and the after saturation point, the torque it will be varies linearly with that of armature current. Okay, so this is the torque versus armature current characteristics. Getting? लक्षात आलं? Hello.
Yes, sir.
Okay. Just 1 minute.